Alright everybody, we are doing notes here again today, and before we start, I'm not going to do an actual trick, but I'm going to do a little illusion you can do with a piece of paper here. So what you want to do is you want to fold it in half twice, look like that, and then fold it one time like this. And then when you unfold it, you should have 8 different boxes, okay? And then you take a pair of scissors, and you're going to cut right here on this line, and right here on this line, okay? And then you're going to turn it around and cut it once on this line, so it looks like that, okay? Then when you lay it down, as you can see, I can fold this side up, and you can see that right there. Okay. You can also do this. This is the trick part of it. You can see the way I did that paper. Okay. It's not obviously the way I cut it. And all I did was just twisted one of these sides like this. So it looks like this. But then when you go, oops, wrong way, like that, you should take those 2 boxes. Okay, that's just something silly, just a little bit of extra time. Okay, so let's get started with the notes really quick. We're going to quickly go through this. We're going to do vocabulary first. Your vocabulary goes like this. Again, we're doing scale drawings and scale models. Okay, so a scale drawing is a drawing that is similar but either larger or smaller than the actual object. Normally it's smaller, and a good example of this, if you think of a map is a perfect example of a scale drawing. Like if you saw a map of Texas, obviously on a sheet of paper, that's not how big the state of Texas is. They've made it smaller, but it actually looks like looks like the shape of Texas. It's just obviously been shrunk. Next, number 2, a scale model is used to represent something that is too large or too small for an actual size model. And let's see if I can do this. If you look, like right here, this house, that would be like a scale model. It's obviously not a real house. It's like a building that someone built, very small. You know, you could walk up, pick it up, and carry it. But it looks like the actual thing that you're modeling it after. So that's what a scale model is. Scale, when you talk about on a map, is used to represent the intervals, which you got to write really small, intervals. Used to represent, I'm sorry, that's already on there. On a map, intervals used to represent the ratio of distance on the map to the actual distance. And what you'll see when you see one of those is you're going to see like a legend or a key that'll say something like 1 centimeter equals 20 miles, something like that. And last, for our vocabulary, a scale factor is a scale written as a ratio in simplest form. And we'll talk more about that as we go. Okay, let's get to the notes part. A map is an example of a scale drawing, like I just talked about a minute ago. Scale drawings and scale models, which was the other thing we talked about, are used to represent objects that are too large or too small to be drawn or built to actual size. The scale gives the ratio that compares the scale drawings or models to the real object, and the measurements are always proportional. And that's what we've been working with the last few days in class, so that's what a lot of these are going to be. Okay, so let's do a few examples. Example 1. It says a model of a tree is made using the scale of 1 inch equals 10 feet. Okay, we're not going to build a model that's the same size as the tree. We're going to make it much smaller. So for every inch of the model, that represents 10 feet of the actual tree. So when it says what is the height of the actual tree, if the height of the model is 4 inches. Well, as you see here, we've got our H chart and we've set it up. The model was 1 inch and the actual was 10 feet, and it's just an easy proportion here. 1 over 10 equals 4 over x. When you cross multiply, you get 40, and that is the height of the actual tree. Okay, you try. So real quick, we're gonna set this one up. Make sure you use your labels out here. You're gonna use centimeters and miles. So once you do that, just hit stop for like a minute, and you should be able to figure that one out. Okay, we're back. So on a map, Dallas is 2.5 centimeters from Rockwall. So I'm going to write the map, 2.5 miles. Okay, and the actual is what we're trying to find. So we know that from the scale that 1 centimeter is equal to 20 miles, and this is what we're trying to solve. So we have our proportion set up for us. If it's 2.5 centimeters on the map, how far is it to Dallas if every 1 centimeter is 20 miles? And again, just an easy cross multiplying. The first one is just 1 times x, which is just x. And when I actually wrote out 20 times 2.5, I would get an answer of 50. Okay, next one, example number 2. A scale drawing of Sonia's room is shown. What are the actual dimensions of her room if 1 inch equals 20 feet? Well, if 1 inch is 20 feet, then 3 inches, this is kind of set up for me, is how many feet? And you would do 3 times 20, which means the real room would be 60 feet, which would be an awesome room, just so you know. That's some room, 60 feet. And the next one, same thing, except we're doing 1 inch to 2 inch. So the 2 would go here, and now we're doing 1 times x is x, is 1x also, and 20 times 2 is 40. So the dimensions of our room are 60 and 40. So all we really did here was 3 times 20 and 2 times 20. And our answer right there, 40 by 60. Okay. Example 3, model of the building. The model of the building. It's just saying you got a building and you got a model of it, and it says the model is 24 inches tall. So the model is 24 inches. It says the actual building is 96 feet. Okay. And it wants to know the scale factor. So what you have to do is you have to simplify this. Okay. But when you do this, you have to make sure that the measurements are the same. And that's a pretty tricky part of this. Okay, so what we're going to do to find out the scale is we're going to make these, we're going to make this a 1, we're going to reduce it. Actually, we can do it either way. We're going to do this where we're going to simplify this. So the scale, if 24 inches is 96 feet, then every 1 inch is how many feet? Well, we're still going to cross multiply. And we're going to find out that the answer down here is 4. So that means every 1 inch equals 4 feet. Okay, so that is the scale they're using. 1 inch is 4 feet. Alright, now you're going to do the U try. And stop it for a minute and do the U try, and then come right back and we'll solve this problem. Okay, we're back. Ernie drew a map of the school. He used a scale in which 1 inch equaled 50 feet. So every 1 inch on the map was 50 actual feet. What distance on Ernie's map should represent the 625 feet between the cafeteria and the science lab? So if 1 inch is 50 feet, then how many inches is 625 feet? So we're doing, once I set that up, Notice I put the feet on the bottom and the inches on the top. We're just going to cross multiply. We get 50x equals 625. And if I took the time to divide that out, I would get 12.5. And that answer is right there. So every inch is 50 feet. So if you think about it, 1 inch is 50 feet, 2 inches is 100, 150, 200. If you counted that way, when you got to 600, you'd be at 12 inches, and then you got another half of 50, 25 of 50, which is 12 and a half. And there you go. So there's your set, there's your videos all done, set for you to go. All right, we will see you in class.